In today's video, we're going to look at some application of the Thales theorem under the enlargement and similarities. So trial 1, let us consider this triangle. Having the calibrations A, let's say let the B be here, B, C, D, and E, and probably this place is, let's say X here, 6 meters, and then the E to C 18 meters, then the BC probably you can see 30 meters, then 15 meters for the DB, and then we have 5 meters for 80, and we want to find X. Okay, we want to find X. So having such, from the previous video, from the diagram, it is clear that D, E, and BC are parallel, right? So solution to find X, since BDE is parallel to BC, then Thales theorem is applicable. Right. So to use the Thales theorem from the previous video, we said that the AD all over dB is going to be equal to AE all over 1 EC, which is as well equal to DE all over BC, right? So we're looking for X, and we can use either AE over EC in relation with DE over BC to find X, or you can use AD over DB in relation to DE over what BC to find what X. So we need just any of these two together with the DE over BC, and preferably I'm going to use this side, that is the AD all over DB is equal to DE all over what? BC. Right. So having this from our diagram, our AD is what? 5 meters. So let's try it. 5 meters. And DB is 15 meters. So 15 meters. This is going to be equal to DE. D is what? X. Then BC is what? 30 meters. So 30 meters. 30 meters. Right. Let's now solve for x. So from this, we consider meters over meters is going to be 1. So 1 times 5 over 15 x over 30 meters. Here, somebody will say m will cancel m, or meters will cancel meters. Yeah, anyway. And then we're looking for x. So here we're going to cross multiply. So we're going to multiply x by what? 15, which is 15x, and then 5 by what? 30 meters. So 5 times 30 meters. And our next step, we're going to find a value for x. And before we could do that, then we need to divide both sides by the coefficient of x, which is 15, right? So we have 15x is equal to 5 times 30 meters, right? So I'm not really multiplying the 5 by 30 because I know that I'm going to be dividing both sides by what? 15, and 5 is a factor of 15, of which I can use the 5 to simplify the 15, or the 15 is also a factor of 30, of which I can use the 30 to simplify it with ease. That is why I did not multiply 5 by 30, right? So here, yeah, let me use, 15 over 15 is going to be 1, and 1 times x is going to give us what? X. Then this side we have 30 over 15. 15 is going to go into itself 1, then it will go into 30 how many times? 2 times. So you're going to have 5 times what? 2 meters. Then we multiply the 5 by 2, and 2 by 5 is going to give us what? 10 meters. So simply applying the Thales theorem, we have been able to figure out the value for x, which is 10 meters, right? Let us take another one. Now, trial 2. Trial 2, assuming that we have a shape of this and that. So in a previous video, we spoke about a truncated triangle. Then we have our calibrations A, B, C, D, E, and F, right? So over here, let's assume, yeah, we want to look for y this time around. Find y, okay. So find y, and then our y is BD, okay. Then the DF is what? 16. This is 16 centimeters. Then our AC is 5 centimeters, and then ECE is 10 centimeters, right? And we asked to find y. There should be something indicating that the Thales theorem is applicable. That is these lines. So these arrows show that the AB is parallel to CD, which is as well parallel to what? EF. Because of this, then we can apply the Thales theorem. To do so easily, from the previous video, we saw that AC was over E was being equal to BD. Please, if you have a challenge, you need to watch the previous video, DF. Right. Now, with this relation, then we just need to do insertion or substitution. right? So AC, what is our AC? Our AC is 5 centimeters. So in place of AC, you're gonna write 5 centimeters. CE, CE is what, 10 centimeters. This is going to be equal to the BD. Our BD is what, Y. Then we got our DF, which is what, 16 centimeters. And the centimeters over centimeters is going to be 1. And 1 times 5 over 10 is going to be 5 over 10. Or as somebody would say, centimeters is going to cancel centimeters out. But please don't cancel, right? Don't cancel. Then Y all over 16 centimeters. Then here we're going to do cross multiplication. Y will be multiplying by 10. So we're going to have 10y. And then 5 by 16. So you're going to have 5 times 16 centimeters. Then to figure out the value for y, we need to divide both sides by the coefficient of y, which is what? 10. So we have 10y all over 10 being equal to 5 times 16 centimeters all over what? 10. Yeah, again, I'm not multiplying the 5 by 16 because I know 10 is a factor of 5 is a factor of 10, of which I can use the 5 to simplify the 10, right? Yeah, so here 10 over 10 is going to give us 1, and then 1 times y is going to be 11y. Okay, then we get to the right hand side. Our 5 is going to go into itself 1 times 16 centimeters, and then so if 5 goes into itself 1, it's going to go into 10 how many times? 2, right? So we have our 2, and then y will be equal to 1 times 16 is going to give us 16 centimeters all over 2. Then 2 can go into 16 how many times? 8, right? 8 centimeters. So therefore our y is equal to what? 8 centimeters. So these are some applications of the Thales theorem under the enlargement